Okay, 8.1. For this section, we're going to be watching the videos as homework. That way we can talk about questions on the videos for the beginning of class each day. And that way you can get more work done in class so you can ask more questions during class and I can help you more. So we're going to start with 8.1. This is going to be combined with 8.2 on your homework. So I can prove whether two triangles are similar using AA, SSS, or SAS similarity. So these are three theorems, and the name kind of gives it away. AA stands for angle, angle, so you have to have two angles. SSS, three sides. SAS, two sides with an angle in between. So that looks like this. So two sides with the angle in between, and these are all on triangles. So similarity is this key word, and similarity means that they are proportional. So kind of like our dilating shapes, they all grow the same amount, so all the angles stay the same. So like if you have a shape like this, then a shape like this, and the angles don't change, that shape is similar to the other shape. And similar is marked with a little tilde, like that. So let's dive into the theorems. The first theorem, AA, means you have two angles from each triangle, and they're the exact same. So in this picture on the left here, we have angle B, and it's marked with one arc. And angle R is also marked with one arc, so they're congruent. And we do the same thing with angle C and Q, but notice we have two marks there, that right there. And this is because we don't want it to look like it's the exact same as angle B. We have to mark it different. And as long as you have two angles marked as congruent, then the triangle is similar to the other one. So similar is written like this. See that little tilde marker in the middle? And we mark it with triangles, so make sure you put those. And you want to write them in order. So if you wrote BCD is similar to RPQ, those are not the same triangles because you didn't match up their angles that are congruent. So like here, B and R, so those are both first. C and Q go together, so if C's next, Q goes next, and then P. Okay, and if there's anything, like if you have vertical angles, you can mark those as congruent. If you have parallel lines, you can mark these alternating interior as congruent. So use what you know from other sections to help you figure out congruent angles here. Okay, the next one, side, side, side. I think this is the easiest. You figure out all your side lengths. So if you have anything that's like a weird shape, like maybe you have a triangle that's overlapping, make sure you look at each actual side length. Like this whole thing is a side, this whole thing is a side. It comes up in the homework, so that's why I want you to be aware of that. For this example, you're going to look at the long side for each triangle, the short side for each triangle, and the medium side for each triangle. And you are setting up fractions, and you're going to see what those fractions actually equal. So like here, if you set up long over long, and then you have medium over medium, you have short over short, all of those equal 3. And you have to make sure they're the exact same number. If they are, then the triangles are similar. And it's a little harder to figure out what triangles are similar. So you want to look, let me remark those. So medium, small, large. So like angle R is right here, is between medium and long. So medium and long, angle B. So that's how I mark it when we don't have congruent angles. The last one, side angle side, mixes the two. So you have to have an angle that's congruent, and it's two sides. And again, you mark those sides long, and short, or medium, whatever you have. This one's actually probably the medium side. Long and long, medium and medium. And these ones do get decimals, so I totally forgot to put the decimals in here. Let's see. So when you divide 56 by 154, we get 0.363636, all repeating. And if you divide 48 by 132, we get 0.363636, same thing. Has to be the exact same decimals for it to count. This one is, so again, you write your similar statement. So let's try a homework problem on the next page here. Oops. So this one here, we want to know if they're similar, and if you don't find similarity, you write not similar if something proves wrong. But we're actually going to look through this and make sure. So we have a congruent angle, so mark it. And then we have a long side and a short side. So long over long, I'm just going to do this. Long would be 54 over 9. So pick whichever one's going to be your top of your fraction. Keep it the same. For the short, we have 30 over 5. And if you solve these, go ahead and try that. You should get 6 and 6. Those are the same. So we do have a similar triangle. U is congruent to A. V is congruent to B. And that leaves C with W. And you say by SAS. Because we had two sides and an angle marked between them. So these problems are super easy. You just got to get the hang of which theorem you're looking at. Problem number 6, let's try that. So we have a congruent angle here because the little triangle and the big triangle both have this angle here. Okay? And then if you notice, we have parallel lines with a transversal, so these angles right here are corresponding. So we know that it is congruent, so we're going to mark the similar angles. L, M goes with Q, N goes with P, and if we didn't use any side lengths, we can't use side, angle, side, or side, side, side. So it has to be angle, angle, because we have two angles marked congruent. You have to show that marking congruent as work. So you have to show the angles congruent. With sides, you have to show this as your work. Oops, let me write that. And that's it.